Hey folks, we are back live at livecoding.ca. It always sounds funny saying live at livecoding.ca, but anyways, I'm your host Nick Taylor, and I'm hanging out with my friend Tama today. Tama, how you doing?
Yeah, I'm good. Thank you. Happy to be here. Thanks for hosting me.
Cool, cool. Now, for folks that might not know you, can you kind of give us a kind of like a quick like who you are or what you do kind of thing?
Yeah, I'm a software engineer. I work at Unsplash, unsplash.com. For everyone that doesn't know Unsplash, we are a kind of like open source library of high quality photos that you can download. And we have a pretty loose license where you can use the photos for both commercial or personal project. You don't have to ask any permissions. You could credit the photographer, but yeah, and then we do have now recently a more like a premium option as well, if you are into that.
Okay, cool, cool, cool. Yeah, yeah, because you recently, I think Unsplash got acquired, right? I think that's what you were telling
Yeah,
me. Yeah.
yeah, we got acquired by Getty Images last year,
Okay.
and then it's been about a year since we've been under their umbrella, and we're
Okay.
kind of like part of the larger product.
Okay. Cool. Cool. All right. I dropped a couple links to where folks can
Awesome.
find you. So Twitter and I don't know
It's
how
good for
often
my
you
clout.
update yours. Yeah. Yeah.
Yeah.
Yeah. Exactly. There you go. You made it. You're Twitch
Yes.
famous now.
I might get a few followers. That's good.
Yeah. So yeah. So what we wanted to talk about today is so like Unsplash is a I would think it's a pretty popular site. I use it at least once a week normally. Like I use it for like blog posts for like images and stuff. And so it's a big site. It supports multiple languages. So we're going to kind of talk about, and I know we were laughing about this last week when we grabbed a drink, but like internationalization versus localization. And I had to look it up again, but basically all those things. And uh, yeah, I guess maybe before we get into that, kind of explain what's the tech stack at Unsplash, aside from super secret stuff maybe, but
Yeah. There's not a lot of secrets, to be honest. So we have kind of like two major part of the application. At least for the
okay.
web app, we do have an iOS application as well. But at least for the web app, we have a backend that is written in Rails, and we
Okay.
have more of the front end, like the front end part, which is a React. It's a TypeScript React application.
Okay.
And we're fully into functional programming. I think we've embraced quite a bit actually. We do pretty advanced stuff there, and we kind of formed
Okay.
a team to that kind of like this paradigm as well. So we tried to leverage as much as we can the TypeScript language to kind of like apply functional programming concepts to it.
Okay. Cool. Cool. Yeah. No, I'm a fan of TypeScript too. As you know, for folks that don't know, me and Toma used to work together at an AI startup, so that's how I know Toma. And that ended up being a pretty large code base at one point when we were converting it. So it was definitely interesting to do. But and just it's just funny because like a few couple weeks ago or a few weeks ago is interviewing Sammy. It's Sammy Jabber, who used to be your old coworker, who now
Yeah.
works at Builder.io. We were talking about
Yeah.
mitosis, so we're all in
Yeah.
Montreal. So it's just kind of it's always a small world.
I watched the stream to make sure he wasn't talking any funny thing about me, you know.
I,
Um,
yeah, yeah. It was all talking trash about you the whole stream. That's
yeah,
what it was.
exactly. Yeah. But
Yeah,
yeah. So I'm definitely it's funny that it's a bit of a coincidence because I didn't know it would be on. But yeah.
yeah. Cool, cool. So okay, yeah. So uh, big into functional programming. We got TypeScript there, and so when it came to adding internationalization and localization to the app, like I know I've had to do this on I think two apps. And when I worked at Autodesk, it was a Rails app, and so they had some like custom stuff with I think YAML and then on the front end we I think what we did was we were duplicating it to generate JSON files maybe, and then in the for folks who have never done any kind of internationalization or localization, you typically have a key so that or some kind of key that's built for like the text. So like for example, like if I just bring us to pairing view for a minute here and like say we come on to the like Unsplash site here, maybe the text there, the internet source for visuals, maybe there'll be some key there, and the actual text is stored in this JSON or whatever structure you have it in, and that's how it gets shown on there and stuff. But I know I know you had tried some things like in React LAN and potentially other solutions and that were out of the box or like existing libraries, and we don't need to throw any projects under the bus, but I think what you were telling me, you were looking to try to use something out of the box and it just didn't seem to fit the needs of Unsplash. Is that right?
Yeah, absolutely. One thing you got to know about the web team at Unsplash, so the us on the front end, we're pretty stubborn, and we have like we're pretty
Okay.
stubborn in terms of like type safety. We like there's a lot of like we design the type level, like we treat the types as like a first class citizen when we design a feature, for example, or like any type of data modeling.
Okay.
And we try to leverage the type system as much as we can, even though TypeScript isn't, the most strict type language in out there. There's definitely like way stricter. Like you have like things like Scala or even Haskell, but
Yeah.
we try to leverage the type system as much as we can into our day to day. So it just helps us in a bunch of ways, but
Hmm.
it helps me sleep at night as well. So like because I know that there's a lot of like classes of bugs that will be caught with
Hmm.
the type system. And to be honest with you, we don't have a lot of tests. Like we do have tests, obviously, with like critical path and like various like stuff that's like really important. And but
Yeah.
very very few tests in some parts because like the types are just enough. They will just catch a lot of these bugs. And you probably, if you look at like stuff like on the TypeScript repo, stuff like that, you'll probably see a lot of
Hmm.
my coworker Oliver that's gonna like post
Yeah.
issues because because as we try to do some stuff with the type system, we encountered like bugs in TypeScript or like just missing feature in TypeScript, stuff like that. So
Okay.
gonna find a lot of tickets on the repo. But yeah, so all that to say that because we're very very strict about trying to bring this type safety as a very big requirement before adopting any technologies or something,
Yeah.
we tried a bunch of tools out there. I think there's like a very popular ones, and I think they're really good at solving that kind of problem, but they were not
Hmm.
meeting kind of like all the requirements that we wanted before
Okay.
bringing anything into the Unsplash code base. And so after like a lot of thoughts, and honestly we've had so many like discussions and a lot of like meetings about what should we do, because there was just a lot of unknowns, right? This is for me, it's the first time I was building any kind of like localization
Okay.
feature. And I think for a lot of us didn't really build that before, so we didn't have a lot of prior knowledge. And then we're like, this is all we want, and we didn't quite found that into what was kind of out there, open source at least. We didn't really look into paid solutions, but so it's like, okay, well, what would it take to just build it ourselves? Like what?
Okay.
Yeah, and then so we kind of listed what do we want, like what do we want out of this solution. Well, type system is a big one, so we want to be able to leverage the type system to tell us if we are misusing I don't know, like you said earlier, like you index the translation by some keys or whatever. So like we want
Yeah.
to make sure we get errors when we try to leverage like keys that do not exist or they have the wrong type. And I'll
Okay.
show you after. I mean, we can watch afterwards how that kind of works. Like I have like a few code samples that I sent you, but
Okay.
we want to also code splitting. Code splitting is a big thing because you don't want to like make the users download all translations for all languages when a user browses in Spanish, for example, right? And
Yeah.
then you have the locale kind of splitting, and you also have like the lazy loading of some component, which should be also split with their translations, because you don't
Hmm.
want to download the translation for maybe like some component that's never going to be loaded for that user, right?
Yeah.
So code splitting is a big thing as well. We wanted something relatively small in terms of runtime code. Like we didn't want to explode the bundle just to solve that problem, right?
Yeah.
And then something that and so when we we tried to like found we tried to find the, technologies that or like libraries that were trying to meeting all of this stuff, and it was kind of actually really hard to do. Like there's something missing every time, so that's why we kind of built it ourselves.
Okay. Okay. And I can't remember. I mean, it's a React front end, but is it a bespoke React front end, or is there like are you using something like a React meta framework of some sort, or are you using like Express and just React or something,
Yeah, it
or
is bare bones React. Like you can't, I mean, as close as the metal you can get with React, this
okay,
is what we have. We don't really have anything. We kind of build our own abstractions to help us with a lot of common stuff, routing and whatever. But it is
okay,
relatively like bare bones React. Yeah.
okay. And I guess just kind of digging into that a bit, did you go that route? No pun intended, but Unsplash is like a media heavy website, and like things need to load super fast, and it's kind of out of the context of what we're talking about today. But like there's all kinds of things you do to make images load fast and so on. And is that one of the reasons why you maybe went with like kind of just bare metal React versus like a framework or?
To be honest, Unsplash is pretty old. I mean, it's not crazy old, but like the React app is probably like I can't remember. I'm gonna say a number, and people might think I'm wrong, but I think it's from like 2015, so it's about 7 years, and it
Okay, so
started.
really early days.
Yeah, yeah, and it started to
Hmm.
yes, it was like React uh, before 14, I think, if I remember correctly. And so
Okay,
it started to grow as a code base. But the solutions that were kind of like available back then within the React ecosystem were not as good as today. Like Next.js is kind of crazy today. It does all sort of like crazy stuff. It wasn't the case
yeah,
before. And also, like, I think we're the kind of team, like, so back then there were no like the solutions were not as good as today. So I think that's why
hmm,
people try to decide to like just go with like just React and then kind of build on top of that.
okay,
Like as the years uh followed by, we always like think like, oh, is it worth it? Just try to migrate. But the code base is huge. That's one
okay,
thing. And the second thing is like we didn't think we'd get a lot of value by the versus the time we would put into trying to like get within the bounds of a framework that already
okay,
exists, right? And then there's a lot of like problems that we already solved, like things like code splitting and whatever, or like things that some framework might give you out of the box, which is like great maybe from new projects, but like we already solved some of these problems. And
okay,
then I think through that, honestly, we got a really good understanding of how the whole thing just works, and we were able to like you know tinker and make adjustments to like very low level parts of the application that maybe a framework wouldn't give you as much control. But I'm not
yeah,
saying like I think if we would just build Unsplash today from scratch, that would be a different decision. We'd probably we go with something else.
yeah. Yeah, for sure. And I can totally relate to working on a large code base that has been around for a lot. Like I worked on a code base that was a Rails backend and it had been around for almost 15 years and they were slowly integrating React into it. And so it's if there's no business value, like as a dev, you might just want to say like, "Hey, I'm going to redo it all. It's going to be better." But there's like when it comes to money, like unless you can convince people like moving it to this or like rewriting the whole thing will bring us x amount of dollars, like if there's no business value, like even if it is like a fun thing to do, that's not a good reason, so
Yeah.
and so yeah, okay, no, cool, cool, yeah, no, I didn't realize the code base was that old, but it makes sense because Unsplash has been around for quite a while, like Uh, I mean, I think it came on my radar maybe like in 2017, but
Oh yeah, it was there probably 2013. That was kind of like the very, very beginning.
okay,
2014 maybe with it was just a Tumblr blog, then it became a Rails application. Then there was the need of building like a separate kind of like full front end application.
okay, cool, cool, cool. Okay, so yeah, so we kind of have a idea of the tech stack, and we talked briefly why existing out of the box solutions for doing the internationalization didn't really fit the needs. So I guess we can kind of talk about like I'll switch us over to coding view, and we can I guess just start talking about like I guess what we're like you were saying you wanted type safety for sure. Um, and I know uh, I'm pretty familiar with TypeScript, and there's a lot of I mean TypeScript's gotten a lot better over the years because like when I started using it in 2015, I mean it was not bad, but it wasn't like amazing. And there's like so many new things now, like infer didn't exist when I started using TypeScript. You know, template strings weren't even a thing yet. I don't think actually. So like, but there's a lot of things that ship with TypeScript now that I'm gonna guess probably make working with keys or strings just a lot easier in terms of what you put in place.
To be honest, I think the way we leverage the TypeScript on that specific part isn't necessarily very complex. It's
Okay.
just I think it's very simple in the idea, but it gives us so much value, and then we didn't find that anywhere else. And maybe folks built it, but it wasn't something that was open source or something like that. But yeah, so I guess like when we started thinking about this, we're like, how can we use TypeScript to tell us a bunch of stuff that we just don't want to have tests for it, or we don't want to have to think about it every time we make a change, right? Because
Yeah.
in JavaScript land, it's pretty easy to just call a function, doesn't exist, and then you get a runtime error, right? So it's
Yeah.
the same principle, right? And so like our localization. So first of all, I think the difference, if I understand it correctly, and I think to this day I still don't, I'm not sure if I fully understand it, but there's a difference between localization and internationalization. And I think internationalization is kind of the process of modifying, updating, or making possible localization within
Yeah.
a technology stack, like a code base or something. And then the localization is actually the process of adapting content for a given locale, like translating tests, formatted dates, numbers,
Yeah.
making sure contextual and cultural changes are made appropriately for the locale you're targeting, right? So like something like something like a locale is composed of two pieces, right? It's like
Yeah.
you like an example of a locale for us Canadian, for example, it would be ENCA or FRCA, right? And so the
Yeah.
first part is often the language, English, French, and Spanish and whatnot. And then the second part is kind of like the region chat slash country code. So it would be CA, US, MX for Mexico, FR, sorry, for France, Japanese, etc., etc. And
Yeah.
so, as you target, like obviously we don't make that quite a sort like difference right now, but there's this differences between American English and British, and so
Yeah.
like obviously at some point we'll want to make those changes within the app. Um, and to be able to all this stuff, we kind of like decompose our infrastructure into different parts. One of the part, and I think there's a file that you can open, which is called the JSON file, like the lang.json file.
Okay. Yeah. Yeah. I'll open
Yeah,
that.
I'll
Yeah. Let
open
me
it on my end
just.
as well. So okay, so
Uh,
that would be a typical file that we would send to translators, and what's gonna happen is like they're gonna like that file goes through some kind of like system, and it spits out translations for all the locales that we support. So we send the English files because we
okay.
that's our main language here, and then
Yeah.
it would spit out. At the moment we have Japanese and Spanish, but there's a lot more coming out, and so it just gives us the same files but like translated, right?
Okay. Yeah.
And
Yeah.
then
Yeah.
that JSON is using a particular standard. It is called ICU, which is it stands for International Component for Unicode, and
Okay.
that is a big standard. There's a lot of like libraries and systems that use the standard out there, and this is actually what the APIs that you find in JavaScript, like V8, whatever, like the
Mm-hmm.
internationalized API uses that under the hood. So,
Okay.
and then ICU is composed of different things. It's composed of like bare static text. So you can see in the first key, there's like your photo. It's just static text, and then the translator is gonna see that and translate that part, right?
Yeah.
And then we have variables, like stuff that just comes from outside the static world. It could be from an API call, and you get data, and you need to insert the data into your string to display on your website. It could be any kind of source. So in this case, username. So it has like the notation of like classical variable notation. We would need to interpolate it at runtime, and then
Yeah.
and then the good thing is ICU supports XML type syntax, so we could see it on the link part on the still on the first key, right? We see view it
Yeah.
on your profile, which is within the bound of a link, and
Yeah.
um, I'll talk about what the backend means after, but that's kind of like
Okay.
that's it. And then we would send that to the translator, and the translator they could rearrange. Like some language, it might not be
Mm-hmm.
the same order of words. Like it's not, like for it to make sense, they might have to like change things, rearrange it. Sorry, this is my cat that just jumped on the on
It's
the
all good.
table.
It's all good.
Um, his name is Dali,
Okay.
and then so they might have to rearrange and stuff like that, but they're able to do so, and then they send us back to JSON with however it was translated, and we'll integrate that. So that's kind of the first part, right?
Okay.
The second part of the infrastructure is we want it, remember type safety. So we want to
Yeah.
to know if all the keys are available to be used, and what kind of parameters we would give them. An example parameter is in this case a username, because username you need to pass it down when you render your string, because it
Yeah.
comes from another source, right? If that makes sense. I have other examples after, but I can we can look at. And then
Yeah.
so we built a compiler. We built a compiler which is open source. I didn't send you the link, but I'll send it right away. It's called
Okay.
Intel
Cool.
C. So I'll
I'll
send it
drop
you
that
on
in the
Twitter.
chat. Yeah.
It's called Intel C, and Intel C stands for Internationalized Compiler, or Internet.
Okay.
I can't remember actually, something like that. And then
Something. Something.
yeah, something like that. And then what it does is like it will take that JSON ICU syntax and generate standard, fully type safe TypeScript code. And
Okay.
what we do is like as soon as the translators send us back the JSON, we compile all that stuff through Intel C, and then Intel C creates generated TypeScript files, and those are the
Okay.
files that are going to be imported into the code base.
Okay.
And I have an example which I sent you,
Yeah.
which is if you look at the, don't know if you can show both, but at the same time, but like like the
Yeah.
JSON file next to the ENES TSX file.
Oh yeah. 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 Sorry, I thought you meant something else. Uh, uh, the JSON and the ENUS.
ENU,
Okay.
yeah, exactly.
Yeah. Okay. Let me just close that and let me just shrink it a
So
little bit.
yeah, so on the right side, this is what Intel C would. I wrote it manually this time around, but Intel C
Okay.
would generate that after taking in the ICU messages, and then it would generate a fully valid TypeScript code that you can actually
Okay.
import these functions into your code, and it will contain all the keys that were presented JSON, and then each is a function that will take
Okay.
some parameters. So we can see in the first one that the function key one takes
Yeah.
a username, which is a string in this case, and I'll explain because we have support for different types, obviously, but which is a string in this case, and then link, it is a function that takes some children and return another React element. And this is where the backend JSX comes into play into the in the
Okay.
JSON. We specify to Intel C what should be the return type of that function. Should it be GSX or should it be just a standard string? Because
Okay.
if you don't need to render GSX, there's just no need to bring React into the scope, and so we just render a string. And
Okay.
if we take a look at both, if we take a look at the JSON and the function, you'll see that we just get we get a plain TypeScript function out of the ICU JSON, and then we just import that function into the code like you would import any other function into your components.
Okay.
The
Cool.
great
Cool.
thing about this is like it is in sync, right? Because it is generated. So as soon as we change the ICU message into JSON file, it will regenerate the function, and the parameters might change, the types might change, but we just leverage standard TypeScript because
Okay.
it's just a function call away, and then you pass parameters, and then TypeScript will just validate your parameters if they meet the right type, if they are like if the properties are correct and if the return type matches what you actually need, right?
Yeah. So, so I guess when when you're doing development, do you have the type checker running for this, or is this more like at build time, like in your CI/CD pipeline only, or?
I mean, if you use VS Code, the language server is gonna kick in and catch, like every
Oh yeah,
time
yeah, yeah.
every time we make a change to the JSON, we have Intel C running in the background that just regenerate these TypeScript file, and the language server picks them up again because they were
Okay.
changed, and then you see live like errors on your editor, and obviously it is enforced at the CI level.
Yeah. Okay. Cool. 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 Yeah. And
Yeah.
I was gonna say, so yeah, like you had the back in there, like TSX or TS. If it's TS, it's just considered more like a string versus
Yes.
JSX. Is that the thing? Okay.
Yeah, exactly. The When you say TS is like you can't like you won't render any React elements, so you wouldn't be able to like pass a like a parameter that returns a React element because the compiler is not going to understand. And then the reason I think we've done it this way, because we could have said like, let's just render every time a React element, right? But it's not
Yeah.
ideal because first we're widening the type for no reason because it is a string at the end of the day. It's not going to be a React element. And so
Yeah.
if you pass this to other parts of your system that needs a string, then you get a possibly a type mismatch, and then that kind of thing. And then the second thing is like the compiler work is heavier to transform the React element because there's just more parsing into DST happening. And so if we
Mhm.
could just skip it at all, then let's just skip it if we can.
Yeah. So like, there's no point to always just have the compiler decide. It's better to just guide it and tell it
Yeah.
it's JSX versus. Yeah, that makes sense. Don't do work you don't need to.
Exactly.
Yeah.
And then maybe, so it is kind of like always in this way, but if we look at the second key, we see that
Yeah.
n is a number now. So we specify the type as a comma, and it's not an Intel C thing, that this is an ICU standard type of thing, right? And then we
Okay.
say n number of photos have been published today, and another variable topic. And if we look at the generated code, we can see that we get a function that takes n, which is a number, and topic, which is a string. When it's
Yeah.
unspecified, it defaults to a string, and then in this case returns a string. But Intel C will invoke automatically the internationalized API that is available in most JavaScript engines. So in this
Okay.
case, it will call Intel number format, passes the locale that corresponds to the current locale you're looking at, and then
Okay.
format the number, in this case automatically, and then we don't really support, like, because like you can pass other arguments to number formats. It's just also the things you can pass. We haven't really
Yeah.
used that, so we don't support that, but it wouldn't be too hard to add. And then obviously
Okay.
the topic here is a string.
Okay. One question I had is, so like in the JSON lang file on the left there, it's pretty clear to me what's going on. There's just a bunch of properties, and one's the actual text to localize or format in some manner, and then the type, whether it's JSX or just regular string. But on the right side, I don't know if it's just because maybe it's because you did it by hand, you said, but like normally in the generated um, React code, the code genning you would do, it wouldn't be the actual text in English for ENUS, right? This is just to show it as an example. Okay, yeah. No, I just wanted to make sure I understood
I
that.
mean,
Like it.
so it would for the English website. So we generate
Oh, okay.
these. Yeah, there's another example. There's another file called ESES, which is empty. I didn't add anything, but that, like
Yeah.
it would be generated alongside. So like basically we run Intel C for every single locale that we support, and we feed it
Okay.
the right JSON for the right locale, and it spits out a TypeScript with the let's say the Spanish strings or the Japanese strings.
Okay. Okay. I think that's the part I misunderstood. So you're generating literally an entire localized site for each language.
we
Is that right?
we we generate lang files, so these kind of files for each locale, and they get dynamically imported based on the locale you're browsing.
Okay. Okay. Gotcha. 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 Okay. Cool.
There's an index file, and we can look at it right now if we wanted to. So the index file is also generated, and what it does is like so it doesn't exactly look like this, but
Okay.
it summarizes the idea. It's like we would import each lookout, because that doesn't code split, by the way, so that wouldn't work for code splitting, but
Yeah.
we'll go back to that later. So we import each languages, and then we create a hook for our components called use translation, for instance, and we tell the
Okay.
hook that the return type is the type of the English strings, like the English lang files. And one
Okay.
super good, like what you see, we see the errors on your end, right? It's because TypeScript knows that if we use this as a base, then it prevents us from forgetting to translate content and change
Yeah.
keys and whatnot on other languages whenever we change
Uh, Okay.
English. So that type checks the actual shape of the object that is kind of exported by the lang file, right? Because the
Yeah.
keys and the type signatures actually match. So if you have key one on English and key one on Spanish, they have to take the same argument and return the absolutely same type. Otherwise, TypeScript is going to complain.
Yeah. No, that makes sense. Okay. Yeah. And using the type of is a nice way to just not have to write the whole type.
Yeah, yeah, yeah,
Yeah.
yeah,
Okay.
exactly. So
Okay. Cool. Cool.
this
Cool.
won't validate the actual um, content, because you can't do that in TypeScript, but we use a checksum to say, like, because what happens is, like, if you change the content of the English, we want to make sure you
Yeah.
don't forget to change the content of the Spanish if that needs to be done. And so we have a checksum, just like a hash that just tells us, like, oh, make sure like you double check this as well.
Okay. So that way, like, you can say like this language can't ship until you have all the translations and
Exactly. Yeah.
yeah. No, that's good because like where I used to work, and maybe other people do this too, but like say like in Quebec it's French English. Well, there's other languages obviously, but like French English. Like say you had all the English translation, but you're missing some of the French. Like I remember, unless I'm mistaken, we used to load English if it was like if it didn't find the French key, it would fall back to the well, not, whatever the default language of the application was, which it got kind of interesting when you're because we would be testing and there was like Japanese, so then you'd have like all this, and I can't read Japanese, but like you're like it was just interesting to see all of a sudden like huge chunks of Japanese and then English, and it's kind of like a mishmash. So I
Yeah.
think this makes more sense saying like, hey, we don't ship it until we have the full translation, and the nice thing too, and this is what we did too, is we'd ship just the JSON file or whatever to the translator. You explain them the conventions, and then it's like it doesn't even have to be somebody super technical, which is nice, and you get obviously well hopefully high quality translations.
Yeah. Getty kind of like takes care of all of this stuff. So they have already
Okay.
systems in place and teams in place, because they have to localize iStock and obviously Getty images. And so
Yeah.
we tapped into that system with with all these changes, and it's been interesting because I think they learn like like a few things from like what we're trying to introduce, and we learn a ton about the whole process of localizing a website and all the pitfalls and all the issues that might come
Okay.
around.
Gotcha. I'm just looking at the Intel C project,
Yep.
and I'm curious what it's built. Well, I'm looking. I scroll down, and it's 95% Haskell. So I guess, I mean, I can guess why you're using Haskell, because you're all big into functional programming, and it's a very functional. It's like, probably, I don't know if it's the top functional programming language, but I guess you went with that decision just because you wanted to have like super type safety, or was it also just like, hey, I want to write something in Haskell, or
There is maybe a bit of both. So someone joined our team, and Sam, and he's been doing a lot of Haskell beforehand,
Mhm.
and I think it helped us a lot, like building this whole thing, and also like Haskell is really good at doing like parsing and ASTs, and it's quite efficient too, right? And
Okay,
so as a compiler, it kind of made sense to us to use Haskell just because it is just really good. Also, Haskell has a feature that not a lot of language have, is it is laziness. So
okay,
it does stuff whenever it needs to be done, or if it needs to be done, but it doesn't eagerly does a ton of work. And there's not a lot of language that have this, and we kind of leverage the Haskell laziness when parsing an AST and stuff like that to still just be like a really efficient process to run on your machine. And
okay.
honestly, like it is really fast. I could look at the latest generation, but it's a couple of seconds.
Okay, cool. I'm just gonna drop a couple links because
Yep.
we're dropping acronyms here. But so
Oh yeah.
AST, for folks who might not be familiar with it, that's an abstract syntax tree. I always find that hard to say.
Yeah.
Um, I'm just gonna drop a link to a Wikipedia link for it. Check that out. But there's and then I'm actually gonna be speaking with somebody about ASTs. Josh Goldberg. He's done a lot of work in TypeScript land. He was on the stream a little while ago, but
Cool.
we're gonna be doing some AST conversions. Um, yeah, I guess the thing about ASTs, like for me, I understand the concept. Like, I'm gonna just switch us back to pairing for a sec. I have AST Explorer open right now, which is a pretty popular tool for kind of seeing this in action. So the AST the AST is basically a format that can be used, uh, I guess, by any AST uh, program that can generate new code, I guess. So, like, I know my own experience has really been more using code mods. Like, when we work together, I've said this before on the stream, but like, when React pulled out prop types out of React DOM, I ran a code mod that the React team provided, and it ran on the whole code base, and it just did the update. So it's cool for things like that, but I haven't actually ever really built anything myself using ASTs, and I'll be doing that in a couple or 3 weeks maybe, but on the stream. But I guess, like, for the Intel C, like, can Haskell handle any ASTs? Like, it can output whatever it wants, or like, just because I haven't really built anything, that my only prior knowledge to ASTs are really like code mods and like JavaScript land, or there was some Babel, I forget what it was called. Ken C. Dodds had made them to allow you to run code mods, but that's like the extent of my work with ASTs. So kind of curious, like, how that plays with Haskell, or like how you all implemented that.
Yeah. So we don't actually use the standard, like, because TypeScript output an AST, right? You have an AST and you can walk through it. TypeScript has an API to do so, and you can manipulate the AST or do whatever you want with it. ESLint does
Yeah.
something similar. You want to lint your code, it turns your code into an AST, and you walk through it and you tell it which node are problematic or how to fix them, etc., etc. In this
Yeah.
case, we haven't really used kind of like the standard ASTs that these languages produce, but we build our own. So we just have
Okay.
a bunch of rules to tell Haskell how to walk through the string and start creating nodes, and creating our own kind of like version of an AST that has types, to
Okay.
help us like represent some particularity about ICU. Like you have a node to represent this is a variable of type string or something like that. And then we just walk through the whole AST. And at this point, we collect a bunch of data and then we just manipulate that data and generate the TypeScript code at the end. Like generating the TypeScript code at the end is actually pretty simple.
Okay.
Yeah.
Okay, gotcha. Okay. And so is the Intel C's job, it's really just to compile these things? That's it? Doesn't do anything else or
It doesn't do
okay.
anything. I mean, sorry, it does have a couple of the features. Sorry, it does have a flattening. So if you go through
Okay.
the repo README, you'll see that it compiles, it flattens. So we flattening is like it's an interesting problem. Is it was something that has to do with the needs of our translators. Is like they wanted to see. So when you have forks into your SU messages, I think I have a very small example in the JSON
Okay.
file, but when you
Yeah.
have forks, so you have to choose one path or another. So if you go to the JSON, the last key has a select. Like there's a
Okay.
select, and what it says is like select when status is closed, then output this string. When status is open, output
Okay.
the other string. This is very simple, and the translator wouldn't need to change that, and they will be able to translate it. But when you have really big um, cases in your select, for example, when the I don't know, the first branch is like a huge string and the second branch is a huge string, the ICU message becomes really, really complicated to read and to translate.
Okay.
And so what happens is like we're able to hoist, so to lift up and kind of copy all the possible case together. I don't know if that makes sense, but it'll create an ICU message. And I think there's an example in the repo, but it'll create an ICU message that is
Okay.
the full message for each branch. And so the translator has just to look at the whole message and translate it all instead of like trying to find bits and pieces.
Okay,
um,
okay, gotcha.
yeah,
Okay, yeah.
I don't know if I explained it correctly, but there's an example that's probably better to look at.
Yeah, in
um,
the Intel C
yeah,
repo
on
you
the
mean?
Intel C repo. Yeah. There's a section
Okay.
about flattening
Okay.
on the
Is that in the
README.
README or
Yes,
okay.
yeah.
Cool. There we go. Fine. Flat. Okay. Here, let me zoom that in a bit. Okay. So hoist selectors up as much as possible. And okay,
See
so
how like see how like the message start with like open source at variable company is, and then you have a select. If
yeah.
company equal unsplash, then calls anchorage, and then unknown is called other is called unknown. But then you see after flattening what it becomes. It basically recreate the whole select, but
Okay.
each branch of the select has the whole message in it. So
Yeah,
if you
yeah. Okay.
yeah, you see like when this on the output, when the company is unsplash, you see the whole message kind of flatten into that branch of the select, and then you have the exact
Okay.
same thing on the other side. So it's just easier for translator to translate.
Yeah, for sure. And when it flattens it, do you unflatten it after, or do you just leave it as flattened?
So I can't remember now. I think we commit the flattened version, but I'm
Okay.
not honestly. We haven't done that much of them. We actually don't have that many forks, and instead we're able to split into two messages instead of creating these
Okay.
very complex messages. But I think we used to commit the flattened version. Yeah,
Okay. Gotcha.
I might be wrong.
Okay.
I
Cool.
can't remember.
Okay. So and so the is the okay, so the intl intel c, sorry, it's hard to say. So it does linting as well as formatting. So does it run prettier on it, or does it
Yes, it actually does. Yeah. It does run
okay.
prettier. And then the
Yeah.
linting is about possible inefficient stuff that you do in your ICU message that might just be a bit more costly to compile or whatever. So it just warns you about
Okay.
it.
Okay. No, that's cool that you're leveraging existing stuff instead of trying to rewrite prettier.
Yeah.
Yeah. And it's got pretty wide support nowadays, prettier, like in terms of languages. I think even when I was working, I mean, I was doing front end, but I dip into the Rails stuff sometimes. I think even Ruby is supported by Prettier now.
Okay,
Like Ruby has a format or two, but basically there's like a huge amount of languages that are
that's
formatted
cool.
with it now.
Yeah, yeah.
But yeah, okay, cool, cool, cool.
And so,
And
yeah, go for it.
now my brain froze. It's good.
Okay.
Uh,
So I guess like just to like so if you remember, so the infrastructure is composed of like JSON file with ICU messages. They get fed into Intel C. Intel
yeah.
C compiles the whole thing into TypeScript function that you can import into your code. It's fully type safe, and is also there's dead code elimination in case you
Okay.
actually. It's just standard TypeScript function, right? So like Webpack is gonna, or I mean, Cursor is gonna kick in and it's gonna say like, oh, you're not actually using this function, so I'm just gonna delete
Okay.
it from your bundle, right? Um,
Okay.
and it is code splittable, but then how do you actually use it into your component? There's an example in the repo I sent you. It's
Yeah.
called my component.tsx,
Okay.
and very simple. It's a standard, you know, functional component, takes some props, whatever, calls the hook, gets the
Okay.
translation object back, and then what happens there is like calls the different function, and obviously these functions are typed. So you can say that the username needs to be a string, and the link, for example, needs to return a React element.
Okay.
um, the key two takes a number, another string, and the key three takes a union. And that is an interesting one. It's like you actually can specify union types. Because
Okay.
do you remember those select ICU syntax that we saw before? They get converted into a
Yeah.
union on the
Okay.
TypeScript side. And then so it is
Like
you
here.
can't just pass anything. It has to be a member of whatever the union is.
Okay, yeah. No, and I just kind of my light bulb just went on. So it's because when I'd worked with keys before with internationalization, the key was always like the message text, and it might be like a string that you format. But here, I just realized that like all the keys are functions, so you get the type safety of the parameters. So that's kind
Yeah.
of cool, I think.
Yeah.
So
And then there's a lot of like features of the language driver that still work. Obviously, renaming it might not be interesting here because like the function name is generated out of the ICU, and so like the JSON would be out of sync and would override again the generated code. So, but go to definition works. So if you want to like check the key one and how it's implemented, you just click, and then that's just a function call. So you just see you go to definition and you see the
yeah.
definition of the function, you know,
Okay.
and stuff like that. And then we were working. We kind of put a pause on it, but we were working in a way of like trying to find a way to go to definition, but go to the JSON file as opposed to go to the TypeScript file.
Okay. Okay.
So
Yeah.
you'd
Yeah.
get to the actual source of that key and you'd be able to
Yeah.
update and then it would regenerate the TypeScript, you know. But I think it is possible as a TypeScript plugin, but like fine, you go to definition, but instead of going to the file, just
Yeah.
go to the next sibling file that has a JSON syntax and try to find the key in there, something like that.
Yeah. Yeah. I wonder if you could also just have a comment that links to it or something that you can click that goes with,
Yeah,
but yeah. But no, this is pretty cool. Because like I said, I didn't clue in initially that you're actually generating components in the functions for the it's not just string stuff, which is definitely where you're getting the type safety because the problem I don't know if it's just where I was working before, but like as soon as you're just dealing with strings, like we couldn't have magic strings, like where like add and when I mean magic strings, it's like if the like kind of like your select, like if this or that, like they all had to be like specific. So like in your code, it would be like if select you would load the full message from the key. Otherwise, load the full message from the other key.
hmm
And so that's interesting. And again, the fact that they're functions is really nice because you get the type safety. And it's all code gen, so that's pretty neat too. So it's like
yeah.
there's a lot of stuff that gives you a lot of safety out of the box, just like this.
There's a lot of like a lot is automated, just to avoid us having to update like many files for changing in translation and whatnot. We're
Yeah.
also there's something I won't be able to show you, but there's like also a CI part that will like we're just submitting whenever you have a pull request. So first of all, because it is TypeScript will warn you about untranslated content. Uh,
Okay.
we cannot merge a PR if we're missing translation. That's just not going to
Yeah.
happen. And so that kind of forces us to always make sure we get translated content for all the features that we ship before
Yeah.
merging a PR. And we've also tried to streamline the process of requesting translation. So we have this like GitHub thing that just fetches the JSON file out of the pull request and then submit it to the system that Gitty uses, and then it pushes a commit back to our pull
Okay.
request with the translation. And technically, the build should be green afterwards because like all the
Okay.
translation are in, so you should be able to merge.
And that's using like some GitHub Actions or something, I guess.
Yeah, it's using just like a standard. It's done on their end, but it's using like a standard like GitHub thing.
Okay. No, that's cool. And I like that this is all automated. I mean, like you do need translate. Yeah, because the solutions I've worked on before, and it's only been on two projects, is it's just manually editing JSON or YAML files, and it's potentially error prone. I mean, obviously, if you get the translation wrong completely, that's another thing, but
Yeah,
that's you assume the translators are going to do a good job. But again, like, I could write a string that was supposed to have a parameter in it, like a template string or something, and then I forgot to add it. It's still being passed in, but it never renders because there's no, it just doesn't end up using it,
yeah,
and then you just get a string that just doesn't look correct. So, you know it's which would come up as a bug, and like it's so yeah, you know it sounds like you put a lot, like your whole team put a lot of thought in how to get this right, and I imagine this didn't take like a week. It is probably like at least a few months, maybe longer. I have no idea,
yeah. It
but
took a while. Give me 1 second. I think my partner is trying to get into the house and it's closed.
yeah,
Give me
yeah,
one
it's
second.
all good, it's all good.
Thank you.
Yeah, yeah. Well, Tomas letting his partner in, yeah. uh, I don't know. Maybe I'll do charades. I don't know. All right, it's all good. It's all good. Yeah,
Thank you.
I was
All right.
gonna do. I was gonna try and do something temporarily, but I just
Uh, yeah, no,
fumbled
the door
and
is right there, but I locked it up by mistake.
yeah, yeah. Well, you're at the same place still, or are you new place, or?
I'm not in Montreal right now. I was just like,
Ah, okay, cool, cool. All right, you don't need to. Don't divulge your location on Twitch.
yeah, yeah, exactly.
Um, yeah, he's in a safe house. All right, cool, cool. All right, so
So
this
that
is like, yeah. Sorry, go ahead.
yeah, I guess that's like almost it, There's another small part that I wanted to touch up before I don't know if there were a question. I actually didn't check the chat. I don't think there is any. But
No,
um
I think it's a lot to take in.
okay, yeah, yeah, yeah. There's a very small part that actually like ties the whole thing together and provides even more type safety, which is sometimes that part is overlooked. It's like how do you make sure your component is actually getting translation. It's not just like plain English text, right? Because you don't want to do that. Like you
Okay.
don't want to create a component and you forget, you just write placeholder text, I don't know what, and then you ship that and you make a mistake and it's not translated. We
Yeah.
actually have a solution for this, and it's very simple idea, but it's actually really powerful. It's what we call a new type. So I don't know if you're
Okay.
familiar with new types at all.
Not offhand. Is it something new in TypeScript, or is this just a general
No,
programming
it's not a
concept?
thing. I mean, there's an implementation in TypeScript. It's called new type TS, but
Okay.
the principle of new type is to create refine narrow type out of a looser type, if that makes sense. So like a loose type would
Okay.
be a string. A loose type is a string, right? But um, a username could be like as a string, for example. A UUID is a string, an email is a string, but those are special strings, right? Like an email is like a very specific format. Um,
Yeah.
a uh, a UUID is a very fixed format, like you know what it's composed of and stuff like that. But from a type system perspective, if you have a function that takes a string, it could be a username, a user ID, an email. It doesn't matter. It doesn't really know. Like the TypeScript doesn't have any way of differentiating these types of strings. So this is where new
Yeah.
types come into play, where You basically create a specialized string, and you tell the type system, you tell TypeScript that this is an email. Like, and then to
Okay.
create that string, you have to decode it somehow, and validate that as an email, and it becomes an email new type, and then you'll be able to pass to this function. But you won't be able to pass
Okay.
any string to that function. And
Okay. Yeah.
yeah, and taking that idea into in the mind is like, we've changed the React base types, and then we created components that, and we replace all the places in the props and whatnot that take string, to take that
Hmm.
new type that we called Intel ZD, which is short for internationalized.
Okay.
And it actually prevents us from passing any string to a title prop or an alt prop of an image component, or
Okay.
as children of a component. It forces us to pass an Intel ZD new type, which uh, in our ends, because that's like a very Unsplash thing to do. So Intel C doesn't do that. We just have like a thing in between that converts the string of Intel C into the new type, and we pass
Okay.
them to the components.
Okay. And obviously that's at the type checking level, but like once it once it compiles, like the alt text on some image JSX is gonna still it's gonna end up being a string that gets put there.
Yeah, yeah. At
So
runtime, absolutely.
yeah.
It's just a type representation. It has no
Yeah.
runtime effect. It's just a plain string.
Okay, yeah. No, that's super cool. I know not everybody's into TypeScript. I mean, I think a lot of people, well, I say a lot of like TypeScript's definitely a lot more popular now, but in the grand scheme of things, like every developer on the planet, I don't know the numbers, but like I'm basing it off those like state of JS surveys and stuff, but it's pretty popular. But I like that idea of the new type because you you definitely want to narrow your types whenever you can, like because that's just when you end up in trouble, right? So
Yeah, yeah, for sure. Um, we leverage new type more and more, and just to represent like a photo ID, to differentiate a photo ID of a user ID, for instance. So
yeah.
you don't by mistake pass a user ID to a function that expects a photo ID and tries to look it up into Redux, and doesn't find a photo because obviously it's not a photo ID. So
Yeah.
yeah, that kind of thing. Just
Okay.
leverage and pushing as much as we can to the type system, so we don't have to think about any of this stuff. TypeScript will just do it for us.
Okay, cool. No, this has been super interesting. I found it super interesting. Maybe it was a little too nerdy for some folks. I have no idea, but no, I definitely appreciate you sharing all this with me. This is super cool. And like you said, the Intel C project is open source,
Yes.
right?
Yeah,
I
yeah, for
have
sure.
no idea. Okay.
Yeah, it is
Yeah.
open source. Obviously, if you there's like definitely open to contribution. There's like, I think we did our best to try to explain how it's built and how it works. This is very Haskell-y, like intense Haskell-y. So like it
Okay.
might be like, it's still very scary to me. I build a few features, and it's, it's a bit scary. But once you get
Yeah.
into the flow, like Haskell is like really really powerful.
Okay.
Um, so yeah, definitely
Yeah.
open to contribution. We wanted to support, because obviously we only support generating TypeScript at the moment. Well, technically we
Yeah.
support generating JavaScript, right? We just have to strip the types. But
Okay. Yeah.
um, with the backend property, this is what drives the compiler, because it sees the backend property of the ICU JSON file, and then just defers that to the right part of the compiler. But we could
Okay.
build anything for any languages. Like if you want to generate Scala code, potentially we could do that. We just have to write
Okay.
the parser for it. But yeah,
Yeah, it's yeah, but like you obviously don't have a need right now, but it's
yeah,
possible, is what you're
yes,
saying. Yeah.
definitely. Yeah, it is open to do that.
Cool. Well, no, this is like you said, you were kind of wrapping up stuff there, so I guess this is probably a good place to stop.
Yep.
No, it's cool hanging out. I've seen you twice in less than a week now, which is nice.
It's like
The boo
200%
pan,
more than the last year.
yeah, exactly, boo pandemic. But yeah, no, it's super cool. I'm gonna drop some links for folks again if they want to give you a follow, and unsplash.com if you haven't checked that out. It's a great place if you just want images for blogs or whatever. Just remember to attribute it to the authors.
Yeah.
Um, yeah, and I was gonna say next week, Chan, aka Chantastic, who works at Storybook and Chromatic, he'll be on next week, and there's two people coming on next week. So that there's one stream on Wednesday with Chan, and then on Friday, I have Simon McDonald from the Enhance web framework and the Begin team. We're going to be talking all about this new HTML first framework called Enhance. So pretty excited for those. Lots of other cool stuff coming on until the end of the year. But thanks again, man, for hanging
Yeah.
out.
Thanks for having
And
me. It was a lot of fun. I hope I did scare people away, but honestly, like it's a it was a lot to build, but I think we're all very proud of what we built, and it just helped us tremendously into making Unsplash more accessible to a lot more folks. And there's like I think 5 new languages are coming out in the next few weeks, so that's just happening.
okay, awesome, awesome, cool, cool. All right, well, thanks everybody for tuning in, and I will see you next week.
Thank you.